Welcome to the lecture series conducted by CEC-UGC. Now I am going to continue with my lecture on arithmetic mean and median. I had already in my previous lecture talked about two properties of arithmetic mean, and now I am going to move on to the third property of arithmetic mean, which is the mean of composite series. Let me say the property first. If xi bar I equal to 1 to so on k be the means of k component series of sizes ni I equal to 1 to so on k respectively, then the mean x bar of the composite series obtained by combining k series is given by the following formula. X bar is equal to n1 into x1 bar plus n2 into x2 bar up to so on plus nk into xk bar upon n1 plus n2 so on plus nk, which is equal to summation I equal to 1 to n ni xi bar upon summation I equal to 1 to n ni. What this property is actually emphasizing is the following, that suppose I will take an example, small example. Suppose I am given 4 series, okay, and in each series, first series there are n1 observations, in second series there are n2 observations, and in third series there are n3 observations, and fourth series there are n4 observations. Now mind you, n1, n2, n3, n4 can be similar, some of them can be same, all of them can be different, it can be any numbers n1, n2, n3, n4. Then I am given the means of those series. That means I am given x1 bar is the mean of first series, x2 bar is the mean of second series, x3 bar is mean of third series, and x4 bar is the mean of fourth series. And if someone asks me what is the mean of the combined series, that means if I put all the series together as one data, then what is the x bar of that data, x bar of that combined series. That x bar of that combined series I can directly find by using these values of xi bar and ni. So then my x bar will be n1 into x1 bar plus n2 into x2 bar plus n3 into x3 bar plus n4 into x4 bar upon n1 plus n2 plus n3 plus n4. That is because I have taken my k as 4. But in the property we do it for general any number k. So therefore here the formula is up to, the sum is up to k. So my x bar is actually, as in my previous lecture I have again elaborated how to write the summation of this type of sums, finite sums. So therefore this will be summation I equal to 1 to n ni xi bar upon summation I equal to 1 to n ni. This property is known as it can be stated as that mean is amenable to algebraic treatment. This is one of the merits of the arithmetic mean. So now I will talk about the proof of this third property that I am going to do, I have just stated. First let us assume the observations on each of the series. So here the first symbol, so let x11, here x11 means what? X11 means first observation in the first series. So the first subscript means the series and the second subscript means the observation. So I have n1 observations in the first series, so therefore the observations can be denoted as x11, x12 up to so on x1 n1. These are the n1 observations of first series. Similarly, x21, x22 up to so on x2n will be the n2 observations of second series, and so on xk1, xk2 and so on xknk will be the nk observations of the kth series. Then let us first write the means of each of these series. Then my x1 bar will be the sum of the observations in the first series divided by the total number of observations in the first series. Sum of the observation in the first series is given by this sum, that is x11 plus x12 plus x1n1 and divided by n1, which is the total number of observations in the first series. So here just I will point out here only that then this sum x11 plus x12 plus x1n1 can be written as equal to, I can take this n1 on the other side, it can be written as equal to n1 into x1 bar. Similarly, x2 bar will be equal to x21 plus x22 so on plus x2n2 divided by n2, and again in the similar way I can write this sum of the observations as equal to n2 into x2 bar, and so on. If I define the xk bar, it will be equal to 1 by nk into the sum of the observations of the kth series. Once I have used the definition, then I have to go to the obtaining x bar. Now what will be the x bar? X bar is the mean of the combined series. That means what I will do, I will put all the observations into one data. I will combine all the observations, and now I have only one series. So we are looking at the combined series. Combined series will have how many observations? Combined series will have observations starting from x11 till k nk. So therefore the x bar, which is the sum of the combined series, will be the sum of all the observations in all the series divided by total number of observations. Now total number of observations will be n1 plus n2 so on plus nk, because n1 was observation in first series, n2 was in second series, and so on, nk was in k series. So n1 plus n2 plus n3 so on plus nk will be the total sum of observations in the combined series, and the sum of the observations will be given by this sum which I have written. I have intentionally put brackets here in the numerator so that you can see that actually I am combining the observations from all the series. Now again, as I had already just now pointed out, that this sum that you have here, x11 plus x12 plus x1n1, these are can be written as n1 into x1 bar using the definition of x1 bar. Similarly, this sum can be written as n2 into x2 bar, and so on. This sum can be written as nk into xk bar. So my x bar will be n1 x1 bar plus n2 x2 bar so on plus nk xk bar upon n1 plus n2 so on plus nk, which implies that x bar is equal to, again compact notation, summation I equal to 1 to n ni xi bar upon summation ni. Now I will just discuss one example based on this so that you can understand how this property is used and what is the benefit of this property. The benefit of this property is that in case you just don't have the original observations, but you have the means of the series and their sizes, then also you can obtain the mean of the combined series. So let us look at question first. So in an examination, suppose 100 male students got mean marks as 65.5 and 150 female students got mean marks as 68. Obtain the mean marks of all the students in that examination. So that means in the examination 100 male students appeared and 150 female students appeared. So total number of students that appeared in the examination is 100 plus 150, which is 250. Now instead of giving the marks, individual marks of 100 male students, what we have is the mean marks of male students, and similarly we have got mean marks of female students. So see, here only I will elaborate. Of course I will write it in show in my next slide. Here if I take n1 as the number of male students, then x1 bar, which is the mean of the marks of male students, it is equal to 65.5, which I will denote it by x1 bar. So my n1 is 100, x1 bar is 65.5, n2 is 150 and x2 bar is 68, and I have to obtain x bar, which is the combined mean, that means mean of the all students in that examination. So what we will do, I will take n1 as, which I have already said 100, x1 bar is 65.5, n2 is 150 and x2 bar is 68. Then using the third property, I can straight away write my x bar as n1 x1 bar plus n2 x2 bar upon n1 plus n2. Put the values 100 into 65.5 plus 150 into 68 divided by 250, and by simple calculation it comes out to be 67 marks. So on average, so what you can say? You can say on average male students have scored 65.5 marks, on average female students have scored 68 marks, but on average any student has got 67 marks in that examination. So here you did not ever need to know what were actually the marks of these male students and female students. It was enough if we had x1 bar and x2 bar. Now once we have done the means, I will now first talk about its merits and demerits. Mean satisfies all the characteristics of ideal measure as laid down by Professor Yule, which are given below. It is rigidly defined. It is easy to calculate and easy to understand. It is based upon all the observations, and by the property 3 we have shown it is amenable to algebraic treatment, and it is least affected by fluctuations of sampling. That means as compared to all the other 4 measures of central tendency, mean is the least affected by fluctuations of sampling. Every measure has its own merits and demerits. So, we will talk about the demerits also. That demerit says that it cannot be located graphically. There are certain measures which can be located graphically. It cannot be used when we have qualitative data. So, suppose you have the favorite color and colors are blue, green, white, orange, then I cannot obtain the mean of that kind of a data. It cannot be obtained if single observation is missing, unless that observation is completely dropped. So, that means if one of the observation is by chance missing, I have to completely drop that observation and then find the mean of the remaining observations, and it is very much affected by extreme values. Now, what it means by very much affected by extreme values? It means that suppose generally the values are between 20 to 30, but there is one value which is 78 and there is one value which is say 2. Then this extreme value is 2 and 78, which might be because observation has got wrongly recorded, or the person who was collecting data was not very alert. But if you have such extreme values, then the value of x bar which we get will be very either much away from the original value. Had these extreme observations been not there, so then it will not truly reflect the data. That is what we mean, that it is affected because we are taking sum of all the observations. So, we will put the extreme observations also into the sum, and as a result what happens is either the value of the mean will become much larger than what it should be, or it will become much smaller than what it should be. Now, we move on to the next measure of central tendency, which is median. The median, it is a value of the variable which divides the entire frequency distribution into 2 equal parts. It is the value which exceeds and is exceeded by the same number of observations. Hence, median is the positional average. So, what I mean to say is that the median is obtained by the position of the variable. So, median is that value of x which separates the entire data into 2 equal parts. What I mean to say is the following. For example, if the median of the marks obtained by students in an exam is 35, so suppose I am given that median is 35, then what does 35 denote? 35 is that mark below which 50% students have scored and above which 50% students have scored. So, if you just count the total number of students who have got marks less than 35, they will be approximately 50%, and if you look at number of students who have scored marks more than 35, then that will be also 50%. So, this 35 is that mark below which there are 50% students have scored and above which 50% students have scored. Now, I will just elaborate it little bit here, that suppose we are given, say there are 2 classes, you must be you have studied in the schools, and every class has sections. So, suppose if I am looking at 2 sections A and B, and I am given that class A the median of the marks is 35 and for class B median is 25.5. Now, I am asking a question, which one do you think class is better, in terms of scoring? So, let us look at what it means. It means that in section A, 50% students have got marks below 35 and 50% have got marks above 35. Whereas in class B, 50% have got below 25.5 and 50% have got above 25.5. So, here in class A, 50% students have scored more than 35 marks, whereas in class B, it is only 25.5. So, therefore, in that sense, we can say that class A is definitely performing better. Now, next comes the question, how to obtain the median. So, we will have 3 levels. First is when we are given the raw data, but the number of observations in the data is even. Then the raw data when the number of observations in the data is odd. Then we have grouped frequency distribution is given to me, that means XIFI is given to me. So, in these 3 cases, how do I obtain median? The method is different for 3 cases. So first let us look at the case when we have ungrouped data, that means raw data is given to me of odd size. That means 11 observations are given, 15 observations are given, 37 observations are given. That means number of observations which are given is odd. So what we will do is we will first arrange the data in ascending or descending order. Then if I represent small n as the number of observations, which is in our case an odd number, so 13, 17, 27 and so on, then the middle value, that is n plus 1 by 2th value from the beginning. So in the data is arranged ascending order or descending order. We generally do it ascending, it's much simpler to do it. So ascending order, then you start from the beginning and reach the n plus 1 by 2th value. That value is the median of the distribution. So let us take an example, it becomes more clear. For example, I have to find median of these 11 observations. Can you see there are 11 observations here? Now so my n is 11. I will arrange them in ascending order because I find it easy. If you find descending order better, you can always do that. But I will arrange them in ascending order. So 12, then 25, then 27 and so on till 67. What I have said? I said you look at which term? You look at 11 plus 1 by 2. That is 12 by 2th term, which is 6th term. 12 by 2 is 6. So that means you will locate the 6th term from the beginning. So beginning is first, second, third, fourth, fifth. So 6th term, which I have highlighted as in yellow, that is the median of this data. So it's very simple, and if you remember this, that you have to locate n plus 1 by 2th term and just put the value of n, then after arranging in the ascending order you will get the median. So median of this data is 36, or median marks is 36. Then when we have median for ungrouped data of even size, so now my n will denote the even number of observations, say 14, 28, 36 and so on. Then definitely you can see when you arrange them in ascending order, in the middle there are always 2 values. In the odd you can always separate them, there is a unique middle value which you get, but here in the middle you will have 2 values. So then the average of the 2 middle values, that is, take the 2 middle values and divide it by 2, that will give you the median of raw data of even size. So that means, so again, since my n is even, I will locate n by 2th term, I will locate n by 2 plus 1. So remember earlier it was n plus 1 by 2, here it is not that. First find n by 2 and then add 1 to it. So then n by 2 plus 1th term, and then you take the sum of these 2 terms and divide it by 2, and that will give you the median. So let us look at go for an example. Suppose I am looking at these 10 observations, okay. 10 is an even number, so my n is equal to 10. I have arranged them first, always arrange them in ascending order, don't forget that. We have arranged them in ascending order. Then first I look at n by 2th term, so 10 by 2th term, which is 5th term, and 10 by 2 plus 1th term will be 6th term, because it is 5 plus 1, 6th term. So I will take the average of the 5th term and the 6th term. So let us see from the beginning where is the 5th and 6th. This is first, second, third, fourth, this is the 5th term, and then this is the 6th term. So I will take 35 plus 36 by 2, so my median is 35.5. Then comes the median for the given discrete distribution. So again, if we are given the discrete frequency distribution xi, fi, then the median is obtained as follows. This is, you have to pay a little attention to the steps because they are slightly more complicated than what we have done so far. So first we will obtain capital N, that is the sum of all the frequencies. Divide that capital N by 2. So that is obtain the quantity n by 2. Then we will obtain less than cumulative frequency for all x. Then we locate the less than cumulative frequency which is just greater than capital N by 2. So mind you, I am looking at the discrete frequency distribution. I am not looking at the class interval type of distribution. I am looking at x1, f1, x2, f2. That is the distribution that is given to me. Then I will locate the less than cumulative frequency which is just greater than n by 2. So these values that I have computed in the second step, I will look which cumulative frequency in second step which is computed is just greater than capital N by 2. The corresponding value of x is the median of the discrete frequency distribution of variable x. So let us do through an example. So suppose if I am given these are the 5 values of x, 5, 6, 7, 8, 9 and these are their corresponding frequencies. So mind you, these will be always given to you. Now how do I find less than cumulative frequency? Cumulative, as the word suggests, you cumulate the frequencies, that means you add the frequency. So first you start with write the first cumulative frequency as same as the first frequency given, which is 8. So start with 8. Then you keep on adding this cumulative frequency with the frequency here. So 8 plus 10 is 18. Then 18 plus 16 is 34. Then 34 plus 20 is 54, then 54 plus 26 is 80. Now I think it is, so when you find it, it's very simple. First write this first frequency as it is in this column and then just take the next frequency and add it to the previous cumulative frequency and then you construct this column. But we should understand what it means. So what it means is the following. If I take 8, that means if I am giving the value of first value of capital X which is given to me is 5. So that means how many observations are less than equal to 5? 8, because there are no observations given to 3, 4, 2 and so on. Only 5 has got 8 observations. So I have got 8 observations which are less than equal to 5. Now if I look at what are the number of observations less than equal to 6. So that means will be the number of observations which are 5 plus number of observations which are 6. Number of observations which are 5 is 8 plus number of observations which are 6 is 10. So it is 8 plus 10 equal to 18. Similarly, number of observations less than equal to 7 will be 8 plus 10 plus 16. So which is 18 plus 16, 34. So that is what this less than cumulative frequency gives. So it gives how many observations less than equal to 5? 8. 18 is the number of observations less than equal to 6. 34 is number of observations less than equal to 7. 54 is number of observations less than equal to 8 and 80 is number of observations less than equal to 9. So below 9 all the observations are coming, right. So here the last term in the cumulative frequency is always matches the sum of the frequencies. Had you find the sum of this frequency, it will be 80. And if you don't get this sum as same as the sum of the frequencies, then you have made some calculation error. Please check your calculations. So now note that capital N is 80, as I have already said, sum of the frequencies. I will obtain n by 2, very simple, it is 40. Then third column we have computed cumulative frequency. I have to look at that cumulative frequency which just exceeds 40. So let me go here. So see, 8 doesn't exceed 40, 18 doesn't exceed 40, 34 doesn't exceed 40, but 54 exceeds 40. This is the first time a cumulative frequency has exceeded 40. So I will locate that cumulative frequency which just exceeds n by 2, which is 40, and then I just go here and hit on this x. So then my median is actually 8. That is what we have to do. We have to locate the cumulative frequency which just exceeds capital N by 2 and then just the cumulative frequency that you get just exceeds, you just locate the corresponding cumulative the x value, and that is 8. So therefore here the median value of capital X is 8. Now comes the part when you have continuous frequency distribution. That means you are given n class intervals and class marks are xi and frequencies are fi. Here again we compute less than cumulative frequency. Now all the performance, all the calculations will be done on xi. Here xi means the class marks. Okay, so we will first be given the class frequency distribution, class intervals will be given, frequencies will be given. I will obtain xi, which is the class marks. Then we will, based on those class marks, I will compute, and then we will have the frequencies. Based on the FIs, I will compute less than cumulative frequency. Of course, I have to obtain the total of the frequencies, which is capital N. Then we locate again the similar way the previous case, we locate the cumulative frequency which just exceeds capital N by 2. But here I will have a corresponding class, not the small value of x. So the corresponding class interval will be called the median class. So here you have to first locate the median class. Once you have located the median class, then the formula has to be used to obtain median. So now median will be equal to L plus h by f into capital N by 2 minus C, where small l is the lower limit of the median class, small f is the frequency of the median class, h is the width of the median class, and C is the cumulative frequency of the class preceding the median class. And of course, my capital N is the sum of all the frequencies. So, again let us illustrate it through an example. So, here as I said, this class interval will be given to you and the frequencies will be given to you. You compute class marks by adding the lower limit with the upper limit and dividing it by 2. So, your class marks are 5, 15, 25, 35 and 45, because 0 plus 10 by 2 is 5, 10 plus 20 by 2 is 15. Once you have obtained the class marks, now using the frequencies, so write the first frequency as it is, then 12 plus 16 is 28, then 28 plus 24 is 52, 52 plus 12 is 64, and then 64 plus 16 is 80. Had you found the sum of these frequencies, it matches exactly with 80. So, my capital N is 80. So, capital N by 2 is 40. So, hence this is the my capital N by 2 is 40. So, what I will do, I will go to this column, look at the class frequency which just exceeds 40. So, you can see this 52 just exceeds 40, 12 is smaller than 40, 28 is smaller than 40, but 52 is the first time that the cumulative frequency exceeds 40. So, then you just go back and locate the class interval, this 20 to 30 becomes the median class. So, we have identified the median class. Once I have identified the median class, then 20 is the lower limit of the median class, 10 is the width of the median class, 24 is the frequency of the median class, and the class cumulative frequency of the class preceding the median class is 28, because the class preceding 20 to 30 is 10 to 20 and that cumulative frequency is 28. So, I will just do the routine calculation and then I will put the values 20 plus 10 by 24 into 80 by 2 minus 28, and that gives me 25. So, 25 is the median of the continuous frequency distribution of the variable capital X. The merits of the median are very simple. It is rigidly defined, easy to calculate, not affected by extreme values. It can be calculated for open-end classes and it can be obtained graphically. And demerits are that it is not based on all the observations and it is not amenable to algebraic treatment and it is affected by the fluctuations of sampling. Thank you everyone for listening to this lecture. I hope you have learnt from it the concept of arithmetic mean and median.